Okay. So good morning, everyone. So, yeah, some echo that you did.
Maybe என்னுடைய சிஸ்டம் நினைக்கிறேன்.
Sankarji, have you joined from mobile? I think.
Yeah, I joined from landline.
Okay. So now there is no echo. So if there is echo, I'll just mute the participants. Yeah. Thank you. Thanks, everyone. So we'll just go through what we were seeing. So yesterday we started seeing HDFS 1.0 and HDFS 1.0, and we started seeing what all the benefits we have and why we went to HDFS. Those things we started seeing, and we'll just start opening this one. And we just saw what is block report, what is data node, name node, what is heartbeat and block, what is a block report that's been sent. And also we have seen what is the edit log and what is FS image, what is the use of secondary name node, and how data will be distributed. Those things we have seen. And then we have seen what is the HDFS and where the HDFS is there. And yesterday we had a question like how the underlying blocks will be, because the Linux blocks that are normally 512 bytes. Linux blocks are just 512 bytes. So how HDFS blocks are 128 MB on top of it. So this we have started seeing yesterday, and how it means is, no issues. And what actually happening under the line is, underline there is a Linux blocks that is 512 bytes that will be still there. On top of that, it will be sequentially 128 MB will be allocated for a single block on top of the Linux, so that the HDFS will store the everything in a single block. That's how it's considered. Let's say this is Linux file system. ext4 is Linux file system. Okay, that is having 512 bytes. This is having 512
how HDFS will ensure that it's sequential?
Yeah, that's what HDFS knows the block IDs, right? So this is Linux file system. This is really like this. The entire hard disk is separated like 512 bytes. Linux file HDFS file system will occupy sequentially like 128 MB and say this is a block. It just stores everything in a sequential manner. Like if it starts from here entirely 128 MB, it will store the same data only. It will consider that is a same one.
So HDFS will have some priority allocation from operating system?
Yeah, it will directly have the access to that. That's why it can write the, like on top of that, it will write its own file system. HDFS is again a virtual file system, right? It is just lying on top of Linux only. So whatever it is allocated to HDFS from Linux, that Linux cannot access those blocks. Those blocks are dedicated to HDFS only. So HDFS can decide what it can do on top of it. So it is just to reduce the head movement. So the sequential of 128 MB will be taken for HDFS blocks. All the sequence will be taken, sequential blocks.
Can this be considered as external memory in the laptop?
In a rough way, for understanding, yes, we can take that as same way only. Because it is not going to change in hardware level. It's going to handle the OS level only, Linux OS level. So that is, we can take it like that way. But it is for just our understanding. HDFS is a file system that is on top of Linux or any other OS. Currently, it supports Linux only. That's how it works. Okay. Got it, Ji? Hello. Anbuji and Ganesh.
Yeah, Shankar, I have a question. Yesterday you talked about heartbeat and the block report, right?
Yeah.
So what is the block report? I bit forget it.
Block
Heartbeat
report,
is the signal sent by the node to the name nodes.
that is heartbeat. Block report is it is also communication from data node to name node, saying that how many blocks I have and what all decommission, what is like block, how many blocks are healthy, how many is not healthy. Those things will be sent from data node to name node. That is block report.
Okay. Thank you.
There are two communication lines. So there is no communication backward from name node to data node. There will be no signal. Always data nodes will be sending signals about the status of the blocks and then the heartbeat.
Sorry. Could you please come again?
Data node will be sending two signals: heartbeat, that is that whether it is alive or not, and block reports will be saying how many blocks it has, how much blocks and what those things. There is always data nodes will be keep on sending the signals to name nodes. There is no return mechanism, like name node will not go and check whether the data node is alive or not. No, it will not happen. Always data nodes will keep on sending the signals. That's how it works.
Okay.
And we've seen secondary name node and heartbeat, block report, FS image and edit log we've seen, and safe mode also we've seen. And yesterday we talked about something called as single point of failure. Let's say this is the name node. There are data nodes. These are data nodes. Name node. Okay, and this is connected to this. This is a network, so that it is already connected. Okay, and if the name node fails, entire system will fail. That's how we saw. If the name node fails, somehow name node fails, then the entire system of Hadoop cluster will be failed, and we have to go again, and then the administrator intervention is required to bring up the name node or whatever it is. But till the time it happens, it is a fail. It's a single point of failure. If name node fails, it's in 1.0. 1.0. If the name node fails, it's a single point of failure. Okay, so in order to avoid this, in order to like solve the problem in 2.0, they introduced the concept called high availability. In 2.0, it is called availability. That is nothing but they will introduce one more name node which will be active all the time. Like two name nodes will be having the FS image and edit log. This will have its own FS image, and this will also have its own FS image, and the edit log is shared. Whatever edits happening in this system, it will be happening in both name node. Whatever data we are putting, whatever things we are putting, it will be stored in both edit logs. So that is a shared edit log. So if in case this name node fails, immediately this will take over. So this is called high availability, and this is achieved using two name nodes installed in the same cluster. That is one name node will be always active. Another one will be standby. Standby name node. Okay. So using this.
So in that scenario, Aruji, so the first one, whatever is the active, the second one is the standby. That won't receive any inputs, right? It will be only the main node will receive all the inputs. Only the main one will go down. Then only the secondary will come up as a primary.
Correct.
Right?
Yeah, that is right. But the edit logs will be shared in both. The edit logs will be there in both the name nodes. It will be shared only. If some edits happening, the edits will be written here and here also. So that then in that case only, if this goes down, immediately it can come up.
Okay. If the second node is, the first one is down, the second node is now doing the primary role. Now the old primary, whatever the fail one, it is come back. then what will happen? So that time that will be as a secondary, or will it act as a secondary, or will it act?
Yeah. So once this primary name node is back, then what happens is this will act as a standby. This will be the active.
Okay.
There is no secondary name node in this concept. Secondary name node is still we can have secondary name node here. And what is the use of secondary name node is it is just combining FS image and the edit log. So in high availability, there is no need of secondary name node. That will be taken care by standby node itself.
Okay. So in that scenario, so always, so once the secondary came up as a active, so until that, whatever the current second standby, it will be wait for that.
Correct.
If it is down, then only it will come as a primary, right?
Exactly.
Okay.
Then only it will come as a primary name node. Then there will serve.
So the one question here. So the secondary will come as a primary, or some other node will make it as a name node, primary name node?
No. Standby name node will become as a primary name node.
Okay. Okay.
There is little bit naming convention we need to follow here. Secondary name node is 1.0. That will not do anything except combining the both. Except combining edit log and the old FS image, and you will create new FS image. Except that secondary name node will not do anything. Okay. Here in 2.0, we call this name node as standby name node. It is not secondary name node anymore.
Okay.
Okay. So if we got, so can we have secondary name node also in 2.0? Yeah, that is possible, but that is unnecessary because it will be the merging will happen in standby name node itself, because it is a free. It's just doing just monitoring the standby. So that merging will happen in standby itself. That's why we don't require explicitly secondary name node in high availability systems. HA, we will call it as HA cluster.
Okay. Okay. What about the inputs from other system to the main node if it goes down?
Yeah, everything will be sent to the here also and here also. Like the edit logs will be sent here also.
No. Like for an example, so we got the signal from other end to the main node, right? The primary.
Yeah, the heartbeat and the block report, right?
Yeah. No. So we got the signal. We got the input processing, right? We got the data for the processing. Okay, we got the data, and immediately this goes down. Okay, how this standby name node knows about whether it received the data into the primary? Also, like how this heartbeat will be taken care if something goes wrong in the middle?
Okay, so regarding processing, once the data is started communicating, then name node has no intervention in that. It will directly taken from here only. So,
Aruji,
yeah.
Can you elaborate on the heartbeat?
Heartbeat is a signal that sends from data node to name node just to say it's alive.
Oh, okay, thank you.
That is heartbeat. Okay, fine. So we'll just read how file is read so that we'll get to know. Okay, so if you see how the file is read, the HDFS client will open and it will the request will be sent to distributed file system, and from name node just the block location will be get from the name node. There will not be any data transfer through the name node in any case, because the data is huge. Directly it will be contact to data node to get the data. So if some processing is reading the files, no, it will not take time. It will just hit the name node and take the block location. In that time, if the name node 1 is failed, then it will automatically go to name node 2. So that's how it works in the cluster. So just to get the block location only, you need name node. After that, you don't need a name node at all, because it will be directly, the data node will send the data to client. It will not go through the name node. No data will pass through name node in any case for processing. So in that case, it will be easily taken care.
No, one question, sorry. So data will not get passed to name node?
Data will not get pass through name node. No, only block location and metadata will be stored.
That means that only for the read access, read function, right? Not for the write function.
Yeah.
For write, it should go to name node and then from name node to data node, right?
No. If you can see the write operation also, the data will never ever go in through name node. If that is the case, then it will be a bottleneck. There is no parallelism at all, because name node will be very bottleneck, right? So it will not happen. This is the anatomy of write. Once you are writing the data, you will just access for the locations. So what happens is, you will just send a create request and name node will give you the block location where the data should be stored. And then the HDFS client will directly write those information into that particular name data node. And then from there, it will take into the next data nodes for replication. So that's how it works.
Haruji, if it is wrong, if I'm wrong, just correct me. I think Anbuji, based on that, the metadata information only stored on the name node, where the data is moving, or where the data is storing, which data node is having the data. That is the information only the name node is going to have.
Correct, exactly. So
okay.
This is data node. That is name node. Is data node.
So for the example given or in the PPT or the PowerPoint, right? So we came to know that name node is going to be going to contact with the data node, right?
Okay.
So for example, what are the examples that we seen earlier?
Okay.
So we see the diagram as data node, name node is going to be check the data node.
Correct.
Right? So that's why I got confused. So
okay.
Now
name node will control whether data node is active or not, whether the blocks are intact or not. That will be controlled by name node, but the data will not fly through the name node. No, that is the only distinction we need to find. Like name node will control the data nodes. That is absolutely the case. This is a thing. This will be controlled. If you want to put some 1 TB file, let's say we are going to put 1 TB file, and in that case, what happens is, if it goes through name node, only one name node we have. Entire data has to go through here and get distributed here. This will be in highly danger. It will be not good for parallel processing. So what happens here is, the client will request for location where it can be stored. So the name node will give you the location. Once it received, this is HDFS client, okay? HDFS client. Then this will put the data directly to the data nodes. Data transfer will happen here. The copying will directly happen from here to here. It will not go through this. It will not go this route. It will not take. It will take this route.
Okay, so the main purpose of that name node is just to give the location. Right?
Exactly. It's just metadata storage and controlling whether the nodes are intact, whether data nodes are available, whether it's alive or not. Those things will be taken care by name node. Nothing else.
It is a kind of a headmaster role, Anbu.
Correct. Master
teacher, the teacher and the student communication is HDFS client and the data node. The headmaster is just monitoring, and he knows who is taking which class and which student is in whose teacher's class, like that.
Okay, now I have a question.
Yeah.
So what is the role of the data nodes? I'll put 2-3 questions with respect to this. So suppose yesterday or day before yesterday, either you or Osman, when they taught, they said like all the data nodes will have an equal amount of spaces. For example, if it is in 10 GB in one, now all the other nodes will have a 10 GB.
Okay.
And the file, suppose a file is stored in one node. So will it be processed in that same node, or it will be shared with the other node and get processed?
Okay. So,
and who is deciding that? Whether HDFS is deciding that, or the node itself is deciding that?
That will be decided by name node.
Where to process the file?
Where to put the file is decided by name node. Where to process the file is decided by job tracker. That is a different daemon. And where to put the file will be decided by name node. because name node knows where the blocks are there, how many blocks are available, everything name node knows.
Okay.
So once you put the file, if you are putting the file here only, you will get the locations, right? This location only, it will be there which data node you should put the files.
Okay. So where to put the file will decide by the name node. I got it. Okay. Where to process the file will be decided by the user job tracker, right?
Yeah, job tracker.
Though it is in one node, it will be spread across multiple nodes.
No. If for conversation's sake, if the entire file is there in this only one data node, it will be processed in only one data node only. It will not unnecessarily move across. Even though there is less power in that, it will wait and process.
Yeah.
So
okay, suppose the RAM is very less in that node.
Even
still
though
it will process. Okay.
Because it is name node job to put the file across.
So only when if the data is spread among all the data nodes.
Yeah, right? Correct. Then it will process. But almost data will be spread across. Always data will be spread across only. But if it is in one node, then only one node will be getting more load.
Okay.
Okay. So we were seeing that.
No, 1 second. Can you go back to the same thing?
This one?
Yeah. No, before. Yeah. So we said that there's a parallel operation, right?
Yeah.
Parallelism. So if you are going to take or if you are going to access the same data node,
okay.
So where is the parallel processing here?
Exactly. We will not be accessing the same data node, right? In the processing, we will access multiple data nodes at a single go. That's why we have MapReduce and Spark. That's why it is got popular. Currently, we are seeing how to store the data only. There is no processing at all we saw. It is just how to store, how to maintain, what happens when failure, how to replicate the blocks, where it is replicated, how can we save it. That's all we are seeing. Just one part. After the processing part will be altogether a different scenario. There we'll have map, reduce, how it's processed, which node it will process. That will be a different scenarios. Multiple max will run, then reduce will run. Here we just take storage only. We didn't go to processing it.
G, in order to bring back the failed name node, so only manual iteration will be required, or is there any systematic process will be done?
Sorry, bring what?
In order to bring the name node online, okay, so only manual iteration will be required, or some system generator way to bring it back online?
If it is down.
Yeah.
If it is down in standby name node, there is no manual intervention required. If we have introduced high availability, then there is no manual intervention required. It will automatically come alive. If it is a 1.0, then yes, there is a manual intervention required.
Okay, okay.
Here, high availability cluster, there is no need. It will take care. And in high availability, what if sometimes it might happen? How the system will decide whether the name node 1 is down, and then when it will know the standby, when it will know to activate the standby name node, because at a given time, only one name node should be alive, active. Another one should be standby. If both name node is active, then there might be a lot of issues. The copying might be done twice, or replication factor might be working differently. Like that, something it might happen. So, in order to avoid that, HDFS or Hadoop has to ensure that at a given time, only one name node is active. So, for that, what it does is, it has a mechanism called failover and fencing. So, if the name node is not responding for a certain period, like 10 minutes, let's say 10 minutes or timeout we can set in the properties. If that is the case, in that case, name node, it's like the Hadoop daemons itself will block all the ports of the particular name node, and then it will make the next name node, like standby name node as active. That is called shoot at the other node's head. That's what they call it as. That is SNOD. That is shoot at the other node's head. So what this means is, it simply means it will just block the port of the particular node, particular name node, active name node, so that it will not come back. So that's one more ensuring done by Hadoop itself. That is called failover and fencing, active and standby name node, and that is done by Zookeeper.
Sorry, still I'm not clear.
Okay, so if the name node 1 is this name node is there, and some network congestion is there, sometimes the network cable is out. In that case, the name node is not responding. Okay.
Okay.
So if then what happens is the HDFS decides, okay, this name node is down. Then it sends a request to standby name node. Then this becomes active. After some time, the network congestion, whatever the network issue got resolved here, and then this name node is also come active. This responded to the query, whatever it is given already. Okay.
Okay.
In this scenario, what happens? Both name nodes are active. Correct?
Yeah.
So that should not happen. For that, what happens is this will be killed by the Zookeeper. This will be killed. That is called failover and fencing. If even though network congestion is there, this port will be blocked and no request will be go there. Whatever requested, that will not come back. So that will be blocked completely. After that only this will be brought online. That is what called failover and fencing. That is a mechanism.
Okay. From initial 2 to 3 classes, we came to know, we have been told like if the file is 50 GB, right?
Okay.
And it will get stored with the 10 GB, 10 GB, 10 GB blocks.
Okay.
In multiple data nodes, right?
Okay.
If that is the case, but just before, like 10 minutes before, you mentioned like, so the data will be stored in only one data node.
No. I never said data will be stored in one node. That is just a hypothesis question. I just answered. It will never store in one data node. That is just a question. I think Sankarji asked, what if happens for the processing sake? It will never store. There is no worries. It will be always distributed. Whatever the nodes there, it will be distributed only. It will never get stored in single node.
Arji, one more question.
Yeah.
Once the standby name node becomes the the master node.
Okay.
So do we have again one more standby node for the, because it's killed already. Name node is the first master name node is killed. So the standby node becomes a master node now. So correct. Will that what happens to the we need another standby node for the currently made a master node.
That is correct only, but currently there is no such implementation. Only if the standby name nodes comes active, then after that the admin has to come back and check what is issue with the standby, and then he has to resolve the issue. After that only it will have again a high availability. Else, if both nodes fails, then it will be a cluster failure.
Okay. So the node name node master node and the standby node automatically automatically brought over. But if it's a standby node is also went away, then manual interruption.
Correct.
Admin will come back and do that.
Yeah. Then admin intervention is required. Yes.
So there is no backup for the backup.
Yeah, correct. There is no backup for standby.
And I just want to add one more thing.
Yeah.
If anyone worked on Informatica ETL tool, then even Informatica has the high availability, and same mechanism there also we can follow.
Okay.
Like one will become a name node, or I think probably Sankar must be knowing this high availability in Informatica, where one will be a master and one will be a standby. And in case if the master goes, there is a time interval where it will check, and if it is master is down, then the secondary will become an active node.
Correct. Okay. Okay.
That is the multi-node if it is installed in multi-node servers. then they'll have.
Yeah, even in if you're going on a SQL Server databases, same thing. One server is always available. The second one is ready. If the first one goes down, second one will come up. So it's not like that we cannot able to go backup. If that is the case, it will go on infinity. So they will keep always 2 servers or maybe 3. So if one is go down, the second one is up, immediately the DBA or administrator will come and fix the one. So automatically the second, the whatever the down one, now it is a secondary. So like that scenario, if you'll add, then it will go on infinity. So they will make it as a 1 or 2. That's all.
The concept is called mirroring in database level in RDBMS.
Yes. Similar way here, Anbu. Same concept.
Okay, yeah, because I'm not aware of the databases.
Oh, okay.
I'm from the pure application side. Like.
Oh, okay, yeah.
Okay.
Thanks.
Arumugam.
Yeah.
So yesterday, day before yesterday, Usman talked about the file edit log and the file image.
Correct. Okay.
File session image. And he told every 1 hour it will copy to the backup node. Edit logs will be copied and there will be a file image built on that.
Correct.
So, and there is a question raised that like, if it is failed within 1 hour.
Yeah, exactly. That is what being sought out using high availability. Because here what happens is the edit log is shared. So it will, even if it is failed, less than 1 node is failed, then another node will have the edit log. So
no, edit log is itself is shared within every 1 hour.
Correct.
So for example, if the edit log is started building the primary node, and after 30 minutes, after 1 hour only, it will be transferred to backup node.
Okay.
So if it is failed within the 30 minutes.
Yeah, that is correct. That is in 1.0 version, that is the issue. If in between it fails, then yes, we will be going into the data loss. In 2.0, the edit log is shared between these 2 name nodes. That means edit log is always up to date in 2 name nodes itself.
Oh, concurrent sharing, always. Every.
For 2.0, that is what we call as high availability. So here there is no point of sharing, right? So here it will take care.
Okay, so it is the name node, data node will interact with the name node 1, and that will be in turn interact with the backup node, or simultaneously it will be given to both nodes.
Yeah, the request will be sent to the data node, name node 1, and name node 1, it will the edit log is shared with into the standby node. So that will be internally.
Okay.
So in 1.0, yes, there will be a data loss. 1 hour once it will go into and merge into FS image. In between 1 hour, there is a data loss. But 2.0, there is handled. So, yeah.
And Arjay, one question.
Yeah.
See, even standby node is connecting to all the data nodes, or only if it is become active, that time it will start connecting to the data nodes.
If it become active, then only it will be connected to all the data nodes. Else, it will not get connected. It will be silent only.
Okay. In that case, let me ask this. For example, you have a name node, and second name node was sending some data to name node.
Okay.
At that point, some network issue happen and name node become inactive. Okay. Then how the standby will establish a connection, and think that standby made an establishment and it connected to all the data nodes. Okay. But there was some transmission happening between data node to name node, and say for example, out of 1,500 packets were transferred. Okay. At that point of time only it had the network issue, and how and the question is whether it is going to send the remaining 500, or it will start sending the right from the beginning, or how that mechanism going to happen.
Okay. So what actually happens is name node will send the it will not send the packet of the information. It will send the block location only. Okay, first it will send the block location where the data is stored, and those block location name node will send it to the client. And let's say while transferring the block location, name node 1 failed. Like,
Okay.
so while transferring the block location, name node 1 failed. In that case, what happened is client will not get the request done. It will be saying that your request timeout, check again. After that, if you try again, then in that time, name node, standby name node, if standby name node become active, then the same block reports will be, the request will be served by name node 2, which is standby name node.
But how the standby name node comes to know that the block's information, because it was not active and it came just became active. So how that information how that information standby will know?
Yeah, it will not know that request is failed. It's a failed request. It will fail only. You will not receive the data.
Then standby is not. So at that moment, standby is not. There is no usage of standby, correct?
No,
No,
no.
even master node also didn't get the information.
No, Anand. Actually, what the point is, the master node is sending the information, but it got failed.
No, master node. No, here master node will not get this information. HDFS client will send information to master node and as well as the standby node. So what R is saying that if the command send both to the same time. If within the second one did not reach, they get the command back saying that, hey, we didn't get your command, send again.
Yes.
No, let me just come back here. I'll just draw a diagram so that we'll explain it clearly. So here is a request. Okay. So I will request for data1.txt file. I want to request the data. It is amounting around 5 GB of size. Okay. So I am requesting it to the name node 1. At that time, name node 1 is active. This is name node 1 that is active. Name node 2 is active. So what happens is immediately name node 1 will get me the blocks where the data is there and from where I should read those things, it will be returned. So again, what will happen is HDFS client, what it will do is it will establish a connection directly to the data node to get those details. Okay, till now it is clear.
Yes.
So now coming to the point, what happens, the request is sent and the name node is failed, correct? That's the question, right?
Yes.
Yep.
So in that case, what happens is the request will not be processed. This request will not be brought to name node 2. No.
Aru, I'm not clear on the first one. Can you please repeat the first one?
Okay. The first one is nothing. It's just one. The data is requested. The block reports are requested, and the block reports will be sent back to the HDFS client, and HDFS client will directly establish a connection to data nodes and get the data. Correct?
Okay. Okay.
That is the positive scenario. What happens? The request receives and the name node fails. That is the scenario which Ganeshji asked, right?
Okay.
Yes.
Correct, right?
Right.
So in this case, what happens? This request will not go into name node 2. No, this will not happen. You will receive a timeout exception, like the name node timeout. You will not receive the signal, something like that you will receive, and this request will not be served. And then after that, again, if you try after some time, then that time name node 2 will be active, then it will go here. So this is a normal case. It usually happens only. Even in your testing local HDFS, this might happen. Like you don't have high availability in your system, but this is what it happens. This request will not get served because the name node 1 is failed.
RJ, the concept of high availability is that even if one master is down, the second system should active and able to solve or are able to fulfill the request, correct?
Yeah, correct.
Okay. In this case, name node is down and it is not getting the timeout error. Then after some point time, it is going to serve from the name node 2.
Correct.
Then in that case, this act as a standalone system. It's not a available. The terminology says availability, but how it solve the request?
Yeah.
When you say after some time, it will be in seconds. It will not be in minutes.
Yeah, it will be in seconds. And one more thing, here there is not data loss in this case, and you are not like losing. High availability means you are not losing the data or block report of already stored millions of files. Okay, and this one request, yes, this will get fail only because it's how currently this is how it happens. Or you can handle this in different way in using your script. Same thing we faced, and what we have is internally we will just check whether which node is active, then we'll send the data to that node. That also in script we wrote, like finding which the name node is active, then we'll send it manually using our script. But one or two requests might fail only in this case while the transfer is happening. That time there will be seconds of downtime will be there. That request will not be fulfilled.
Even this thing, Ganesh, even this thing is available in all the RDBMS also. The first node is down, the second node will convert it as a main node. It will take few seconds. So that time we need to wait. Sometime that is the reason we used to say that a network issue or something. We not even know that the second node is a primary now. So it's
becoming primary. Okay.
For that. Yeah.
But in 1.0, this will be completely, you will have to wait for 1 hour or 2 hours, even sometimes you don't even get the data back. But in 2.0, that is being reduced to seconds, and at least some of the requests will not, while the transfer is happening, some of the requests might fail. Yeah.
Okay.
When you say some of the requests, then we have to resend the request, or the same request will be again triggered against it, against the other node.
We have to send the request again. We will receive a message of failure or timeout, then we have to send it again.
So maybe we have to handle it in the program then.
Yeah, correct. We have to handle the scripts. That's how we do.
Okay, fine. I got that point. But now I have another question. You said edit log is being shared between name node 1 and 2, correct?
Correct.
Okay. In this case, name node 1 is down.
Okay.
So in that case, what will happen to the edit log?
Edit log is already shared. Here also it is there. Shared means both have the same copy. So if this is down, this edit log is same as this. So that will be used.
Okay. But till name node 1 comes back, there are some other blocks are consuming it's happened, and name node 2 is been updated. Okay. Or our edit log is been what do you say, added, within that blocks been updated. So when name node 1 comes back, will get the replica or will get the updated one, or what happened that time?
No, see, when name node 1 goes down, whatever it is serving, whatever the request, let's say it is serving 500 requests or 1000 requests, all the requests will fail immediately. There will not be coming back of those 1000 requests, whatever it is, if it's a write or a write request or read request, whatever it is, that is down. That's it. 1000 requests fail only. There is no coming back of those requests. And if somebody is writing the data into the system in that time, if it is not written properly, if it is in the middle of something, that will not be written into the edit log. So those data is failed only. They have to write again, and that edit log will not be there in name node 2. That is failed only. That records they have to write it again. Yes.
Okay. Is there any checkpoint whenever the main name node goes down, whether this has been successfully written into the data node or not?
There is not check. It's not. There is nothing like checkpoint or something. There is a request completion of the copying. Whether the data successfully copied or not, that's what you can get. But you don't have any checkpointing how this transfer is done, like where it is completed. No, that is not possible. Only what is possible is you have the control of whether the data is successfully copied or not. That's what control we have.
No, just in case if it is not processed by the data node 1, sorry, name node 1. So if that is the case, whether the name node 2 can take it forward to process it?
Automatically it will not take it. We have to handle it in our program. We have to check whether the copying is completed or not. If it is completed, fine. If it is not completed, try again.
Okay, I think that is the area that Hadoop need to improve.
Yeah, it is still improving, correct. It's 2.0 only, it is correct. These cases are very common. This will happen, like I face it almost 1 in almost 1 month once I face this. Such
so, then if it is halfway writing into node 1, data node 1,
okay,
or the process happened halfway, so what will happen to that? So they will kill that, or
will be again available.
What are you saying?
Like let's say 10 GB data is there, 5 GB is wrote into half of the blocks, and that time name node goes down and it is not yet registered. Those blocks contain the data .txt. It is not registered in data edit log. In that case, those blocks will be considered as an empty block only. Something else will be written on top of it. If some other request comes, that will be used for that. So the request incomplete.
So again we have to rewrite.
Correct. Again we have to rewrite in that case. And this scenario is not, it's not going to happen all the time. It happens sometimes, rarely only. If it is huge cluster and something like that, it might go down. But name node going down is not, it will not happen often. That's what we saw.
Okay.
But request failure sometimes happens.
Can we test these scenarios when we are doing that?
These scenarios we will not be able to test in our system because it is not high availability. You will be able to test only in corporate clusters, high availability enabled clusters. Here it is just one single this only. We can check about the blocks and all. Like we have few comments and practicals. What we can check here. This exact scenario, entire scenario, we will not be able to test.
Like, is there any point of thing like we can bring down the data node and try to write into the data node?
But that is altogether admin job. So we will not like we can try it out, but that is not entirely used for admin or even architecture. So if you want to try, you build a system with high availability with 2 systems, and you can bring down one and you can try those things.
Okay.
So but that is entirely admin's part only. We will not have any control.
Okay, through this HDFS concept, so we are not going to deal with anything, right? So
no,
this is only a concept for us.
We're just understanding so that we can write the programs better. If we know like some of the things we covered for interview perspective, because why we have a block size and how to process those things architecture needs. Like one system architecture need to know what is the best size, what kind of format you should choose, what is best for HDFS, what is the block size, how it processes. That's why we are seeing these things. This availability also.
Okay.
If something node goes down or something, developer has no issues at all, we just have to mail to the admin team, they'll take it. But we have to know what's happening. That's it. Okay. So this is what happens entirely with the HDFS concept. So there is one more concept that is called federation. This is one kind of interesting one, HDFS federation. So HDFS federation is something like, let's have one node is there. Like I'll just put HDFS, entire HDFS, this is HDFS path, okay? So in this path, I can have multiple name nodes, active, multiple active name nodes. This is one name node, this is one name node, active name nodes. And this for a single cluster itself, for a single HDFS cluster, I can have multiple name nodes and I can serve the metadata of different particular paths, like path of the files. Like I can serve this into user data1.sales. Whatever the data is stored under this directory, that will be served by this name node 1. Whatever the data is there in another folder, which is /user/data2.hr. whatever the data is stored under this particular folder, that will be served by data node name node 2. Both are active at the same time, and this will have its own standby. This can have its own standby. So this is possible. This is called HDFS federation, which means you can have multiple name nodes in a single big cluster itself and serving to the different paths, different folders. That's what is possible. That's called HDFS federation. Multiple name nodes. Okay, so who will use the federation? Why do we? Okay, everybody understood what is HDFS federation?
Yeah, yes.
So who will use it? If some of the companies are too big, and we already know name node is a special node. This should have the large memory, large RAM should be there so that it can serve. So if some company have very large data stored in everywhere, and the name node, single name node is not able to handle everything, in that case they will segregate this single node. They will make it as two name node, two cluster. This is also entirely done by admin only, but we just need to know this, what's HDFS federation and why it is used. If there is huge, then we can have multiple name nodes separated, because a load will be shared, and this will be shared to this folder, this will be shared to this folder. We can define that. So in that case only we'll go for HDFS federation.
But say I can bisect and I can have a single cluster for each department. I can, that way it will be easy to maintain, correct? Instead of going for federation.
Correct. That is also fine. That also you can have. But it is purely, again, it is an admin decision. This is possible. I've also never seen anybody using this facility, but it is still there. But sometimes it will be, it is not considered to use a different cluster. There will be some of maintenance cost or something. Maybe that's why they go this way.
I think this one is Ganeshji, why it is this kind of situation is required. Suppose if it is a single system, if it is the federation method, for the admin it is easy to monitor. Or unless suppose each server, they need to keep it in a separate monitoring system. They need to do the monitoring. Got it?
Okay, from monitor perspective, I agree with you. But if my, say for example, sales name node is out for some reason, from the maintenance perspective, if I have a single entity where I know that it will be easy for me to troubleshoot it. But within this cluster, I have 5 departments, and for example, 2 departments, 2 name nodes went off. So I have to troubleshoot and bring it up back. So that time, do you think being it in the federation will be easier to maintain rather than having it in individual clusters?
Actually,
monitor wise, I agree. It is a single entity where we can monitor entire, within that umbrella, we can monitor all the entity. I agree that. But from the maintenance perspective.
Actually, here also it will fulfill the similar method like you, right? You sold each department. Here it is the same way. Suppose we have a 5 department. Suppose you are saying a 5 individual system. Instead of that, they are build a one big cluster. Under that, they have a 5 separate name nodes. Each node serving is each department, and each node have a secondary node. So if I know my first department related stuff is down, then automatically in the same monitoring system itself, admin came to know, anyway, they will fix it. Instead of logging into the different server, they will came to know, they will log in into the different server and they will fix it. I am in one server. I am in, it is easy for me to monitoring and easy to fix it and reboot.
Okay, but the network is common to across the cluster. It's not individual entity, correct? So how do you segregate the network for each cluster, each department?
No, here the thing is, that's the reason, right? He is telling, right, the user data 1 sales. So that is for sales department. The HR is 2. That is a different file path. The third one may be finance. That is going to be a different path. So each one have a different set of name node, and the secondary node.
So that means you will have a different sub-mask or something, subnet or something.
Yeah, that is the way I understand that HDFS federation. Am I right, Aruji?
Aruji.
Yeah.
So federation means multiple same nodes.
Yeah, correct.
In what way it is interacted? Can you please repeat again?
Federation is nothing but you can make one single cluster work as you can altogether it is a single cluster, but it will be internally it will be split into multiples. Like you can have two name nodes and it will be point to only one folder or one particular path which you find it's necessary to segregate. That you can do.
No. In a cluster, I have five nodes.
Okay.
Out of which you are saying that one will be considered as the two name nodes, or one node will be how it will be two different nodes will be a name node.
Two nodes will be considered as two name nodes.
Okay.
One node is considered as one name node. Another three node will be data nodes.
Okay. So no, where the storage location will be in one system, then.
No. Storage.
So what you are trying to say?
Everywhere. That will be everywhere only. That block.
Okay, then where the federation comes now?
Different.
Shankar, consider this: you have name node 1 for sales department, and name node 2 for HR, and name node 3 for marketing. Okay. If it was an individual, and we combine all the three and put it in one cluster, that will become as a federation.
Yes.
See, the point is.
Then okay, what will be the backup for those?
It will have its own. Each name node will have individual standby.
Yeah, individual standby.
Correct.
So one will be standby to other.
No, each one will have its own standby.
Yeah, each will have its own standby only. One will not be other standby. It will be two more systems will be there. There is one name node. This is two name nodes, and this this has 20 GB. This has 20 GB HDFS space. Okay, this is 20 GB of HDFS space. Totally, it's 60 GB. Okay, totally it's this 60 GB of size. Total HDFS space. HDFS is 60 GB of size. So the 60 GB that is being served by these two name nodes. Like this 60 GB is it will be like this. Correct. Virtually, I'm just saying virtually, it will be like this. So here you can like point particular folder to this name node, particular another folder to this name node. So that will be served by that. Blocks can be stored anywhere in three nodes. That is possible. But only blocks will be identified by this name node. That is the scenario over here.
Okay. So in federation, only the name node and standby will be in different, but the data node is common across all the name nodes.
Exactly. Correct.
Yes.
Okay.
That is called federation.
That's called federation. Got it. Okay.
Okay. And one more thing which is data rack awareness. So if you see racks and all, this will be like this. Data nodes and racks will be like this. Okay. So this is cluster. This is how cluster will look like. If you go into big clusters or Google cluster or something, even whatever the clusters, the cluster will look like this. This is the clusters, and this is called racks. Racks, and this is called nodes. Node is nothing but RAM and memory. That is called nodes. Okay. So if we make let's assume this is a Hadoop cluster, and you are putting one will be acted as a name node. Here one will be acting as a name node, and another will be data nodes. Name node, and all the other will be data nodes. Fine. Till now, everybody clear what we are trying to do?
Yeah. Yes.
Okay. So this is how the cluster setup will look like virtually. Even though if you go, any cluster will look like this only. It will be stored as a rack. This is a physical way of looking into the cluster. This is how it will look like. Okay. So you put one, let's say we are storing one file into our Hadoop, and we kept the replication factor as 3. Replication factor is 3, we kept it like that. And here we are putting the data. So the data is written into this data node. Let's assume data is name node given the location, and data is written into this first copy of the data will be written into this node. Okay. And the second copy of the same data, because the replication factor is 3, second copy will be written into the same rack, different node. This is second copy. This is copy 2. Same data, copy 2 will be written here, and the third copy of the same file will be written into the different rack, different node. So this is because this will be taken care by Hadoop itself. Okay, and why this is being split like this means, if this node fails, then data will be recovered from this this node. And what if the entire rack fails? If the entire rack is failed, then what happens? We will take the data, we can still recover the data from this node, right? Understood?
Yes, yes.
So I'll just repeat it again.
Yeah.
So we are copying the data to HDFS cluster, and we set the replication factor as 3. And then if we set the replication factor as 3 and this is our cluster setup, then the first replication will be stored into the different node of the same rack. First replication, first copy will be stored in the same first copy stored in same node. Second copy stored in different node in same rack. Third copy stored in different node, different rack. So this is called rack awareness. And even if you can keep on further going, let's say 4 will also stored in different rack. And let's say you have 2 clusters. That might happen sometime. You can take the backup of the same cluster and create one more backup. That will be 4. That will be keep on course.
So ideally, if they have a single cluster, they will try to do it in a different rack.
Yeah.
If they have multiple cluster, definitely they will copy it in across the clusters.
Correct.
They will not keep it in single cluster.
Correct. So the point here is storing in such a way.
Not single cluster.
If this node is failed, we can still recover the data from this node. If the entire rack is failed, we can still recover the data from this rack. That is the entire point of storing this way. This is called rack awareness. This is done by Hadoop itself. Provided you have provided the switch details, everything properly set up, then this will happen automatically. Got it? So everybody got this concept?
Yeah. Yes, I'm fine.
Yeah.
Yeah. So this is called, we call this rack awareness. We'll just see some of the important Hadoop comments so that we will get to know about Hadoop. So some of the comments what developers should know is how to find a Hadoop version. Okay. So I am just now entered into this Hadoop, and first of all, how do we access a cluster? So this is a cluster. First of all, how we will hit the cluster? Any idea? Which node we will access the cluster?
Name node?
Okay. Any other way? The data node we can access?
No, repeat your question.
This is my cluster. Through which node I can access the cluster? Through which node I can access the HDFS? I just want to access the HDFS. Which node I will hit? Which node I can connect to access the cluster?
You can connect to any nodes.
Exactly. You can connect to any node. That is the point. I can connect to this data node, or I can connect to this data node also. If I have like 1,000 nodes, I can connect any one node and I can get the access to Hadoop HDFS. Okay.
Okay. Here I have one question. If it is not in the same cluster, then still is it possible?
Yeah, it is possible. You have to use the proxy. This is proxy.
Okay.
Through proxy you can access. That's how the security is done in production system. So production systems, you will not be given directly access to any data node or any name node. No, that is not possible. So what happens is they will give you the one proxy node. There will some IP is there, something like that. IP, different IP, something, and on behind node, it will be connected to this node. So you will not get to know the IP of the data node or name node, but still you can access the Hadoop. That is proxy. This is how we access. Got it?
It is a kind of a, it's kind of a GUI kind of thing.
GUI is also possible. That is using tools you can install. But mostly what developer will access through PuTTY. Let's say.
Oh, okay, I got it.
So everybody else got it? Any doubts in this? How to access?
No.
So let's connect the same way how we are going to connect. Here, this is my Hadoop. I'm just into the system itself. Here I have GUI, IF, config. I have the IP address coming. This is 192.168.64.123.129. So we'll just connect it through PuTTY. So here I came to the Windows and I'm opening my PuTTY and I'm just giving the host name, paste, and port is fine, SSH is fine, and I want to save it as Cloudera 44. I think I already have 4, that's why. So I'm just saving it and then I'm doing open. So it's opening. Cloudera, and then it connects. So again, you can see, right? Now I'm connected to my Linux from my Windows itself using PuTTY. This is how we will do exactly the same in production itself, or whatever the live environment will do the same. So is it now, can you connect to my system from your system using the PuTTY? Because that's the IP address, right? Can you connect? Any idea? Because it's just the IP address. Can you connect from your system using the PuTTY using the same IP address?
Provided if you give access, the port is open, then we can connect.
Exactly, that's the point. So if we can give the port open and there are some settings which we need to mention in the our this Cloudera VM, then you can also access. That's how it works. Okay, so now I've just connected from my Windows to my Linux, and that Hadoop is there. So this is how our system will be. This is how we'll access everything in our environment. I hope I'm recording this. Okay, so I'll just run some of the commands. How to find the Hadoop version? It is very simple. How do you find? I've given you one Linux system. How do you make sure the Hadoop is installed in the system? All we can do is Hadoop. If you just type Hadoop, if this command comes, then yes, Hadoop is installed in the system. And then Hadoop version, I'll just type Hadoop version. It will show me the version of what version we are currently using. We are using currently Hadoop 2.0.0, CDH 4.4.0, which is Cloudera. I think Sankarji, I'm muting it. So CDH is Cloudera 4.0 version we are using, and all the other things are fine. This is a version we are using. If you install 5.3 or whatever it is, there will also you will use those particular versions. Okay, currently what is the version? This is the older version. We are using it because somebody might have less memory, so that's why we are using this 4.4. This works with 2 GB RAM itself. Currently the latest version is 5.15, I guess. And the most of the production companies, they are using 5.9, CDH 5.9 they are using. So if you have more than 8 GB of RAM, you can use the latest version, which you can download from Cloudera site itself. Fine. This is a way how to check whether the Hadoop is there or not using Hadoop version. And then how to verify whether Hadoop services are run or not. These are all common services, the thing only. You can just write services status all. If you give like this, it will show what are the services currently running. Plume NG is not running. HBase Solar is not running. Cloudera SCM agent is running. ActID is running. So there are multiple ways to check these things. I'm just giving you some commands for the initial way. There are one more way to check. There are GUI ways, there are admin ways, there are a lot of ways. And how to start process and stop fail is not running, that we can do using service command. That is also fine. And how to find where the blocks are. So there is one command is called FSCK. This will show where exactly the blocks are there. Okay, I'm just doing clear. So this will exactly show what is the this will show what is how many replicas there and how many blocks, total size of the blocks, whether it is healthy or not, and what is the total size, what is the how many directories are there, how many files are there, total blocks available, and minimally replicated blocks. 100% minimally replicated, and over replicated is 0, under replicated is 32. Something is not replicated properly. Default replication factor is 3, average block replication, everything. Those status you can see. Whatever we till now you can see.
But whatever the total block is for one all the data nodes, correct? It's not
correct. Only one data node is there here.
Okay. Either way we can find how many. Oh, okay. That will give you number of data nodes.
In this cluster there is one. In this cluster only one data node is there, right? So if you go into multi-node cluster, then this number will change.
Got it. I didn't see that in data load.
Okay.
The number is okay.
Hello?
Yeah.
Yeah, when it has a multiple node, will it display node by node or
no?
It will give a summary.
The entire node combinedly this will show like this.
Okay.
That is the states, total states. I'm just putting this into assignment folder. You can try this.
Aru, can you show this? How did you go to the putty here? Like, you're not working on the Cloudera, right? You're not working on the Hadoop system.
Okay. So what is Cloudera?
No. You're not working on the. You're in a putty, right? You're connected through the putty.
Correct.
But you ask us to download from Cloudera Quick Start VM.
Correct.
So from here you connected there, or like both are same?
Both are same. Like it is Linux system. I've connected from my Windows. So both are same. Inside also I can do the same. I will get the same results. But this is inside the server.
Right. Okay. Yeah, that's my question. So I can use the same thing what you did over there.
Yeah, you can use the same. You just have to download putty and then configure whatever I did. That's it. Then you can connect. Or you can directly come into terminal. You can come into CentOS, right click terminal. Here also you can do the same. Same will work.
Okay.
Same result you will get. So that's fine. So I'll just give one scenario. Let's say this one scenario just for you guys to think, just for ideas, right? And I have a input folder. Okay, this is my Linux, right? This is my Linux. This is my Linux, and this is my HDFS. HDFS. And there is one web server. I have one web server. Yeah, I have one web server. This is my web server. Okay. So my web server daily generates around 2 GB of data. And the data file, it will be generated as a data in a file called .log. Okay. The file naming convention will be weblog _ 27 _ 09 2009 and 2018, something like that. It will be there. So this will be my daily log. Today log will be like this. It will be the date. Okay, something like that. I will receive the logs daily. Okay. So using FTP. Everybody knows FTP, right? Using FTP, the data is pushed to my Linux. Okay, there is data is pushed to the Linux in this folder. Let's have one folder /data /in path /local weblog. Okay, it will be stored in this folder. So daily I will receive this file into this folder. I want to push the data into Hadoop, into HDFS. I want to push the data into HDFS daily. As soon as the file arrived, I have to push the data into HDFS and load, and I'll do whatever I want to do. I'll do Hive or processing or something like that. So can anyone just think of the idea of how we can handle this scenario?
Yeah, daily we can write on a shell script. That script will check. We can put it in the Unix cron tab, so it will check every 3 minutes or 4 minutes or 5 minutes, and it can, whatever the file name starts with the web log star something, so it will push the file whatever the target path, like a FTP script. So it will because if it is on a same, because the web server is in a different path and the file is on a different server, so we can use it on a FTP from the web server file path to the HDFS file path. We can push the file.
Correct. So from here, the FTP, from here we'll write a shell script.
Okay. RJ, I will summarize it as a two-way. We can do as a event-based or time-based.
Okay.
Yeah.
Whatever Vinodji or Anbuji said, it is a time-based. Within some cycle, we can go and keep on check the log is available. If it is there, we can push it. Whereas we can have a event-based. Say, for example, I can put a token file. Once I get a weblog, I can send a token file to kick my shell script, which will go and pick the data and push it to HDFS.
Exactly. So
I think you guys are familiar with the Unix.
Yeah, correct. So everybody gets the idea of the solution. What is the solution? We'll go into the part of Hadoop where this is like normal things. Whatever we do, this is how we do. If the data comes, then we write a shell script and it will push, and whatever we'll intimate, we'll schedule the job using multiple tools. We have AutoSys or whatever, a lot of tools are there. So everybody get the point of the solution. I think Ganeshji, Selvamji, Anandji, and Nanbuji, and Shivaramji, and Vigneshji.
Yeah, yes.
Yeah, we are clear.
Yeah. So, yeah, I guess everybody is expert in this scenario. So, this is Vigneshji, is it fine? You got it?
Yeah, got it. Yeah.
Fine, super. So, this is how we do it. And for this only, we will be needing like the data. We got the data here and inside a shell script. So, everybody said that's exactly right. Using the shell script, we can push the data. So, if here I said the data time, the period of the data is 1 day. One day only one file we are receiving. So in this case, we don't have to go for any tools in big data, anything, nothing. All we can do is just write a simple shell script to handle all these things. It is so simple. We don't have to go for a scoop or flume, or we don't have to worry much. We can write a simple shell script and then we can do it. And in that inside, all we have to do is using put command, just to push the data to Hadoop. That's all we can do, because a lot of simple solution we can provide for this kind of scenarios based on the timing. So that's what I'm trying to mention. And once the data is inside here, we will push it into the one folder, one HDFS folder. In one HDFS folder, after that, initially what we'll do is we'll do the cleansing. From here, our actual job starts. So what we can do is we will write some code to clean the data and whatever we want, because weblogs, we need to find whether it is unstructured or structured or semi-structured, what is the data. After that, we have to accordingly process the data. First, we need to clean the data using any script. Sometimes we use Spark script. Sometimes we can just write Hive table and then we can write a query to handle these things. Sorry, spelling mistake. Clean data. Okay, so that's how it goes. We have the same scripts also available with us. We have tried this. You can try this and run this one. And before that, you can just you can write the HDFS commands and try this out in these days. And except the processing part, you can try those commands. Except the jar. Finally, we have one jar file. This you can just ignore this one. Hadoop jar word count, that we can just ignore. That will come to that. Once we write a jar file and then we can export and we'll run this program. Other than that, other things you can just try to push the data and how to delete RMA. Those are exactly similar like Linux only. Just all you need to do is add append Hadoop address. Okay. So this one we have wrote a script. I'll just add the script in our class folder. Projects. Visualization practice completed. Java fix practice sample data selection. So this is called daily load. We make it as a daily load and we wrote this simple script which will load into Hadoop. So I'm just adding this into our folder, assignment folder. You can go through it and you can create a setup and you can run it. It has a sample data also like weblogs. These are the weblogs which you can use for your own practice. This is nothing. It's just we have to just extract these two from this IP address and the date. This is the Wi-Fi root data. So you can use this to practice. This is very simple start one only. So I'm just copying this into our folder. Assignments, HDFS, everything is HDFS only. So this you can write. This is tool one. 3 KB.
That has an Linux commands also. Linux commands.
What?
No, that has a Linux commands too.
Linux commands. That HDFS commands is as Linux. You can we have a separate session in that one, so that you can see. I'll just share the details. You can use that to see the Linux command. That is here we provided on Linux command. I'll just Linux command configuration. Okay. This one you can watch for Linux introduction. It has all the commands and all the information. This one you can watch. I'll just copy it here also. HDFS commands, Linux introduction. You can watch this one.
So the picture is yours?
Yeah.
Okay.
He put someone else, Sankar.
Yeah, sorry.
No. I was just pulling my cousin, Sankar.
Okay. Okay, so this is any other doubts in this one? Whatever we saw today, we saw HDFS and HDFS high availability and 2.0, and what is the use of HDFS and why we need it, and all these concepts, safe mode, rank awareness, and most of it is we need to aware and it will be asked, and for architecture purpose we need to know. For that we need to understand all those things. But if you face any issues or something like that, we will go for the admin team only, because we'll be focusing into development more. So any other doubts in this?
We are good.
Okay.
I am
Okay,
good.
that's
Sorry.
fine. Yeah. How about Ganeshji and Anandji, Anbuji, Shankarji, and Salamji, and Shivramji, Upniji?
Yeah, I'm good. I have to go through this.
Yeah.
So what we
Good.
can do is we'll just go through. You can go through this session one more time also, and then we can start. If you have any doubts or something, you can post in our group, and you can start the discussion going. Because if you have doubts, somebody else might already know the answer. Or if you know the answer and question, you can post it as well in our group. You can make the group active so that it will be more useful and somebody can remember something. So something like that. And yeah, so we'll be wrapping up the session today. And next session we will not be having session in next Tuesday morning because it's a long weekend. We'll be going out. So that third morning, Wednesday morning, we will have the session. Wednesday morning IST. So that your Tuesday night we will have USC Tuesday night we'll have the next session. Okay. And yeah, that's it. If any other queries or updates, I'll post in our WhatsApp group so that we'll all in the same page. And in meanwhile, you can try those HDFS comments, and then whatever the small script we have given, you can try to run it. And then if you face any issues, you can post in our group and get the solution also. And yeah, so that's it from my side. Thank you. I hope today class is useful and interesting, and it doesn't make you sleep, I hope. And yeah, we'll see you in the next class. Thank you. Thanks, everyone.
Thank you. Thanks.